In this lesson, we're going to switch gears a little bit and start doing something called polynomial long division. Basically, this is like long division with integers, but we have to then consider variables. So to start out, we're going to review long division with integers. Our first problem is 1,519 divided by 7. This could also be written as a fraction or with that division sign. So we're going to write it with the division sign. And when we're doing long division, basically we're first going to say how many times does 7 go into 1? And it does not go into 1, so then we need to move down and say how many times does 7 go into 15? It goes into 15 2 times. 7 times 2 is 14. I'm going to erase this because this should not look like division. I was just underlining the 15. So 7 times 2 is 14. We write that below the 15, and then we subtract. 15 minus 14 is 1. And then we bring down the next digit. And basically from there, the process repeats. So how many times does 7 go into 11? 7 goes into 11 one time. 7 times 1 is 7. We write that down here and subtract. So this gives me 4. We bring down the next number, which is a 9. 7 goes into 49 7 times. And 7 times 7 is 49. So on this problem, we have nothing left over. Is there a remainder in this division? The answer to that question is no. So looking at the next one, now it says, now evaluate 1,522 using long division, divided by 7 using long division. And we're going to write our answer in a different type of form. So we should notice that 1,522 is only 3 bigger than 1,519. So this problem is going to look really similar. But we're going to have a remainder at the end. So I'm just going to do the parts we've already done kind of quickly. 7 goes into 15 2 times. We subtract and get a 1. This time, the next digit is a 2, so I bring that down. 7 goes into 12 one time. 7 times 1 is 7. When we subtract, we get 5, and this time we bring down another 2. 7 goes into 52 7 times. 7 times 7 is 49, so on this one, we have 3 left over. The 7 doesn't fit into the 3 again. I'm done with bringing down digits, so we could write this as a remainder. Now, what this means is 7 goes into 1,522 217 times, plus we have 3 out of 7 left. So we didn't get up to 218, okay? But we have a fraction left, so 3 out of 7 is how we can write that answer. Now this is a little weird. Usually if we were writing this with, if you were younger, if you were in elementary school doing this for the first time, you'd write 217 and 3/7. That plus sign is something we have to include with the polynomial long division, so that's why we're getting used to it here. So let's look at our first problem where we have variables, where we have polynomials. So here, I have 2x squared plus 15x plus 18 divided by x plus 6. So we set it up the same way. The x plus 6 goes on the outside. Now it's a little different here. We only, when we decide what we're going to write up top, think about the first term in the number that's on the outside. So basically we say how many times does x go into 2x squared? Okay, how many times does x go into 2x squared? Now, I know that's 2x. I'm going to write that up here. If I have trouble figuring that out, I can write 2x squared divided by x on the side. So I can take this and divide it by that, and I can see that if I canceled, that would give me a 2 and an x left. So that's where the 2x comes from. Now from here, everything's pretty similar. So whatever I write up top, I'm going to take this entire piece and multiply it by that. So I'm going to draw arrows. We don't usually draw that, but the idea is I'm distributing it to these two. Erasing that just so we have a little more room and it doesn't look so confusing. So 2x times x is 2x squared, and 2x times 6 is 12x. And then just like when we had the integers, the next step is to subtract. Now, subtraction with a binomial we know means we have to distribute that negative sign. So the way I suggest doing this is to put this in parentheses, and we're going to change all the signs. So I'm going to change this to addition, change that to a negative, and then also change the sign because we're distributing at our negative, and then we kind of ignore this outside sign and we just follow what we see. So 2x squared minus 2x squared cancels. 15x minus 12x is 3x. Now this first part should always cancel like our 2x squareds did if we put the right thing up top. The next step, like with the integers, is to bring down the next number. So that's plus 18. And then I start the process over again. So now I'm saying how many times does x go into 3x? So x goes into 3x 3 times. If I did 3x divided by x, I would get 3. So up here I'm going to write plus 3, and then I'm going to distribute. So I'll erase these other arrows. Now I am distributing my 3 to the x plus 6. So that will give me 3x, right? 3 times x is 3x. Let me get a pen. 3 times 6 is 18. And then I subtract. So same deal, make it positive, change each of the signs. The 3x's cancel again. The first term should always cancel. 18 minus 18 is 0. Okay, so this goes in evenly. We don't have any remainder. So this is the answer to the problem. Now, this brings up a point. If something goes in evenly to something else, if one polynomial, in this case the binomial x plus 6, goes into another polynomial, that means that x plus 6 is a factor of 2x squared plus 15x plus 18. So this is yes, and the reason is there is no remainder.